For the rest of the examples in this lesson, we're going to use symmetry to help us find probabilities. So in example 7, it says the amount of time it takes for a delivery truck to travel from the warehouse to a distribution center is normally distributed. Let X represent the travel time in hours. The mean travel time is 4 hours with the standard deviation of 0.5. So this is important. The mean is 4 and the standard deviation is 0.5. We're given that the probability that X is less than 3.5 is 0.1587. We're going to sketch the graph and then we're going to use that information to find the probability that X is greater than 3.5. So we have our normal curve shape. The mean is the center, so that always needs to go right in the middle. And our standard deviation is 0.5. So when I come out to my first standard deviation, I want to imagine about where my inflection point is. This is where it goes from concave down to where it starts to go concave up again. So I'm going to imagine that it's about right here. So when I come out 0.5, that means this part on the graph is 4.5. And then if I come out that same distance again, that gives me 5. And then I get 5.5. I could keep going, but I'm going to stop at 3. Usually there's not a whole lot of data past 3 standard deviations out. So this is 1 standard deviation out. Then if I go out again, that's at 2 standard deviations. And then if I go out again, that's 3 standard deviations. Now going this way, I'm going to subtract 0.5 because I'm going in the left direction, which means less than. So this is going to be at 3.5, then at 3, and then at 2.5. So it's the same thing. I'm going out 1 standard deviation, 2 standard deviations, and 3 standard deviations. I'm just going in the left direction rather than the right. Now it tells us that the probability that X is less than 3.5 is 0.1587. So less than 3.5 would mean I'm looking at this shaded area right here. That's the area under the curve that's less than 3.5. Now, because the graph is symmetric, when we're dealing with the normal curve, if I fold that graph in half, where the mean is where I would make my fold, I would have the same area on the other side. So this area right here would also be 0.1587. So I can also say that the probability that X is greater than 4.5 is equal to 0.1587. So that's what we mean by symmetry. The question, however, is asking us for the area under the graph that's greater than 3.5. Everything greater than 3.5 I'm going to put in red. So that's all of this. So that whole area represents the probability that X is greater than 3.5. We know that the total area under the curve is 1 or 100%. And since we know that the probability that X is less than 3.5 is 0.1587, to find the probability that X is greater than 3.5, we just have to take 1 minus the probability that X is less than 3.5. So our answer is going to be 1 minus 0.1587. And when we put that in on the calculator and find that value, we get 0.8413. For example 8, we have the number of pages in a novel is normally distributed. Let X represent the number of pages. The mean number of pages is 300 with a standard deviation of 25 pages. We're given that the probability that x is less than 275 is 0.1587. We're going to sketch the graph and find the probability that x is greater than 275. So this is very similar to what we just did. We're just using a different situation. Here's our normal curve. The mean always goes in the middle, so that's 300. We have a standard deviation of 25 pages. So when I imagine where my curve goes from concave down to concave up, that's going to be where my first standard deviation is going to be. So about right here. So to go to the right one standard deviation, that's going to give me 325 because I'm going to add 25. Then to go out another one, that's going to give me 350. And then for the third standard deviation, I have 375. Now going in the other direction, I'm going to subtract. So this is going to be 275, 250, and then 225. So here's the sketch of my normal curve. We have that the probability that x is less than 275, that's this area right here. That probability is 0.1587. We need to find the probability that x is greater than 275 because we know that this area to the left of 275 is 0.1587. To find the area to the right, which is greater than 275, I just got to take 1 minus the probability that x is less than 275. So we're going to take 1 minus 0.1587, and we're going to get the same answer as above because it's the same idea. We're going to get 0.8413. Example 9 says the scores on a standardized test are normally distributed. Let x represent the test score. The mean test score is 80 with a standard deviation of 10. Given that the probability of x is less than 70 is 0.1587, we're going to sketch the graph and find the probability that x is between 70 and 90. So here's our curve. Our mean goes in the middle. It says the average is 80, and we have a standard deviation of 10. So that means I'm going to keep adding 10. And I'll subtract 10 going in this direction. So here's the sketch of our graph. We're given that when x is less than 70, that area under the curve, or that probability, is 0.1587. So that's from here to here. We need to find the probability that x is between 70 and 90. So we need to find this probability. Using symmetry, I know that this area over here is also 0.1587. So to find the blue area in the middle to give us the probability that x is between 70 and 90, what I need to do is add up 0.1587 plus 0.1587. That will give me the total area in those two tails. And then if I subtract that from 1, what's left over is what's in the middle. So I'm going to take 1 minus, and then I'm going to double 0.1587. That will give me the two tails added up. And when I subtract it from 1, I'll get the area between 70 and 90. So when we put that in on the calculator, we get 0.6826. So that tells me that the probability that a student is going to score between 70 and 90 is 0.6826 or 68.26%. Let's look at example 10. The height of adult males in a city is normally distributed. Let X represent the height in inches. The mean height is 70 inches with a standard deviation of 3. Given that the probability of X is greater than 74 is 0.0912, sketch the graph and find the probability that X is less than 74. So here's the sketch of our graph. "70 is the mean, so that's going to go in the center. We have a standard deviation of 3 inches. So each time I come out, I'm going to add 3 to the right. And when I come out, each tick mark to the left, I'm going to subtract. So that's going to give me 67, 64, 61. We're given that the probability greater than 74, so 74 is in here somewhere. So from here over, greater than 74, this area under the curve is 0.0912. We want to find the probability that X is less than 74, so that's everything else. So what I need to do to find the probability that X is less than 74 is I need to take 1 and subtract off 0.0912. So the probability that X is less than 74 is equal to 1 minus the probability that X is greater than 74, which is 1 minus 0.0912. And when we work that out on the calculator, we get 0.9088.